We modern humans have been living on this planet for nearly 300,000 years. When we analyze this time frame, we've been experts in many different fields like art, language, science, architecture, and medicine. But for a long period of time, the base for human development was manpower and animal power. So whoever had more of this force, they created the strongest kingdoms. During this time period, humans ran their lives only using their muscle force. They used animals to automate some things. So no matter how much expertise they had in fields like art, language, architecture, and culture, their development was very slow because of this. The development that happened in the last 150 years is many times more than what happened in those 300,000 years. The reason for this is science and technology. To elaborate more, many innovations happened in the last 150 years. Some of those innovations took our civilization to the next level. One of them is electric motors. Most of the gadgets and products we use have this electric motor in them. We've understood the benefits of these electric motors and implemented them in many applications, adapting accordingly. So we need to know the story of electric motors that help us this much. And definitely, when you finish watching this video, you'll not only understand how to use a tech, but also have the satisfaction of knowing its backstory in 10 minutes. Even before discovering electricity, they started researches about electric motors. This research happened in early 1740s. Initially, the electric motor they created was based on electrostatic energy. So this became a failed model, because to run a powerful electric motor, you need higher voltage. Due to the technological limits at that time, they couldn't achieve higher voltage. And they fixed this problem one day. In 1799, a scientist named Alessandro Volta discovered the electrochemical battery. This invention was a starting point for the electric motor. Later, in the 1820s, they discovered that the electric current produced by these electrochemical batteries creates a magnetic field. Using these details, a scientist named André-Marie Ampère understood the attraction and repulsion forces in this electromagnet within a few weeks and presented Ampère's force law. Finally, a person named Michael Faraday demonstrated his first motor in 1821. In that, they had placed a wire dipped in mercury with a permanent magnet. As soon as they passed current, that wire started to rotate around the magnet, and this is the first invention of the electric motor. The invention of electric motors didn't end here. After this, every scientist that came kept innovating using the best technologies available in their time period. In today's modern world, we use different types of electric motors suitable for different applications. To understand the use case of these electric motors, I'll give you an idea. Count how many gadgets in your home work based on electric motors. You'll understand for yourself. We've seen the story of electric motors all this time. Now let's see how electric motors work. There are two types of electric motors. First, AC motor. This runs using AC current. Second, DC motor. This works using DC current. There are two important components in electric motors: rotor and stator. We call the part that rotates in a motor the rotor, and what holds this total structure is the stator. In most early motors, they would wind a coil in the rotor. That means they would wind copper wire around it. We've definitely seen this, but didn't know what it's for. When you connect electric current to a copper wire, a magnetic field is created in it. But that magnetic field will be weak. That's why we wind copper wire in one place to make the magnetic field strong. The magnetic field created like this interacts with the magnetic field of the permanent magnet in the stator and creates a rotational force. And to continue this rotational force, they keep changing the magnetic field. This is the general understanding of how an electric motor works. And for different motors, the placement of the coil in the rotor and the placement of the magnet in the stator will change. Some motors run on DC power, and some motors run on AC power. These AC motors are used in big industries in places with heavy loads. DC motors are used in portable electronics and robotics. Based on the applications, whichever type of motor fulfills the requirements in which place, they choose accordingly, because there are many types of motors. Each type of motor is built differently. We're going to look at some interesting motors among them. And these days, many people are using electric vehicles, so we're also going to look at the electric motors in them. First, BLDC motor. This is called a brushless DC motor. In this type of motor, they place the magnet in the rotor part and the coil in the stator part. Through an instrument called electronic speed controller, you can control the magnetic field in the coil, so a rotational magnetic field is created, and the magnetic field of the permanent magnet in the rotor synchronizes with this and the motor rotates. This synchronization means when the magnet in the rotor aligns with the rotational magnetic field in the coil. That is, at one point, these two magnetic fields meet and become a single magnetic field. This is what we call synchronization. It's because of synchronizing magnetic fields like this that we get rotational force in the motor. Second, induction motor. This type of motor works on AC power. The stator of an induction motor has a coil. That's all. The rotational magnetic field created in this coil induces in the rotor. That means in this type of motor, there's no magnet in the conductive material of the rotor. The rotor itself has to create the magnetic field needed for this. How? When a magnetic field is induced in a conductive material, electric current is created in it. At the same time, when you pass electric current through a conductive material, a magnetic field is created in it. So think about this. The rotational electromagnetic field created in the stator induces in the rotor. The current created because of this creates a magnetic field in the rotor. This magnetic field interacts with the magnetic field created in the stator and creates a rotational force. This is how an induction motor works. Finally, PMSM motors. This is called a permanent magnet synchronous motor. The working of BLDC motor and PMSM motors is similar. There's only one difference. That is, BLDC motors run on DC current, but PMSM motors run on AC current. And this type of motor is what they use in many electric vehicles. We've looked at 3 interesting electric motors used in most places. Apart from this, there are many different types of electric motors. Many researches are happening to improve these electric motors further, and those concepts are very interesting. If you liked this video, please like and subscribe to this channel. And if this concept was very inspiring to you, there's a lot more you need to know. So do your research. I'll see you in the next video with interesting content like this. Thank you.